I've decided to divide a long and complex video over ionic bonds into three separate videos. Part 1 of this series, the video you're watching right now, will lecture on how ionic bonds are formed and their physical properties. The second video will cover how to read and write ionic compound notation. And the last video will cover the 3D structure and properties of ionic compounds. Lastly, just to clarify, an ionic bond is the electrostatic attraction between oppositely charged ions. An ionic compound is the result of many of these bonds arranged in a repeating lattice structure. With that in mind, let's begin. And let's start with a very simple question. Why do atoms bond with one another? It seems like so much work. Why would they ever do it? The reason for this is the extra stability that comes with moving to a lower energy level. You need to know that atoms bond with one another in order to form more stable compounds. I have here a chart that shows on the y-axis the potential energy of two atoms, and on the x-axis their intermolecular distance from one another. These are our two atoms. You'll see that as the distance between them decreases, their potential energy also decreases, until at a value of 50 units, their potential energy is at the lowest. This is where the bond would form, because the two atoms are the most stable. If they get too close, however, they will start repelling one another again, and the bond will break as the potential energy increases. So this chart pretty much explains why atoms bond. With a low potential energy, they will form a happy bond with one another. Focusing exclusively on ionic bonds now, what even is an ionic bond? An ionic bond is when two atoms, commonly a metal and a nonmetal, form a bond by transferring one or more electrons between one another. Let's imagine that we had a sodium atom, which is a metal, and a chlorine atom, which is a nonmetal. If the chlorine were to snatch an electron from the sodium would become a positively charged cation, and the chlorine would become a negatively charged anion. The resulting electrostatic attraction between these oppositely charged ions is the ionic bond. Again, atoms form bonds to be more stable. The closer the number of valence electrons of an atom is to 8, a full octet, the more stable it will be. So atoms will either transfer or share valence electrons with one another in order to reach this goal. A full transference can really only take place if there is a very large difference in electronegativity between the atoms, which is why we say that ionic bonds exist between metals and nonmetals. A small side note. Differences in electronegativity between atoms is truly the best way to predict which types of bonds they will form. Let me show you the formation of an ionic bond in greater detail with a drawing of our sodium-chlorine example. As with all my videos, I sincerely apologize for my horrible and lopsided circles. So this chlorine atom has 7 valence electrons, and it really wants 8. This sodium atom has 1 valence electron, and it really wants 8. If this chlorine were to randomly find an electron, it would get up to 8, a full octet. And if this sodium were to lose an electron, well then it would also have 8, a full octet. You can kind of see what's starting to brew here, right? Chlorine has an electronegativity of 3.16, and sodium has an electronegativity of 0.93. Now, I do chemistry because I'm not the greatest math person in the world, but even I can see that there is a great difference between 3.16 and 0.93. This chlorine atom is a lot more electronegative than the sodium atom. So what's it going to do? It's simply going to snatch this sodium's electron. And once it's done that, this chlorine will become a negative anion, and this sodium will become a positive cation. Because the chlorine is now a negative ion, and the sodium is now a positive ion, there will be an even greater difference in electronegativity between the two. And this difference will cause an ionic bond to form, which we can imagine is this blue line. Again, what you need to take away from this is that after the more electronegative atom snatches an electron from the less electronegative atom, the difference in electrostatic attraction between the two atoms will be so large that a full ionic bond will form. And after this bond forms, the sodium and chlorine atom would be very close to one another, as you see in this infographic. I was simply too lazy to redraw my drawings, but you should see that the sodium and chlorine atom are literally hugging each other. You gotta keep this in mind because this explains the structure that ionic compounds will form. But congratulations, you now know what an ionic bond is. Which brings up our final question of this video. What are the properties of an ionic bond? Because ionic bonds involve the full transference of valence electrons, They are the strongest out of the main three bonds, those being ionic, covalent, and hydrogen bonds. This means that ionic compounds will have higher melting points than compounds containing covalent or hydrogen bonds, as the ionic bonds will take more energy to break. Ionic compounds, which are many of these ionic bonds arranged in a pattern, will form a crystal lattice structure, and this explains the rigidity and strength of ionic compounds. For a more in-depth look into the properties of ionic compounds rather than bonds, please watch part 3 in this video series. And that wraps up part 1 of ionic bonds. You should now have a strong understanding of why ionic bonds form and their physical properties. For a further dissection in ionic compounds, please look for the latter parts in this series on my channel. Thank you so much for watching.